All right, today we're going to look at the side, 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 and the side, angle, side congruence postulate. So these are two congruency postulates that we're going to use to prove that my two triangles are congruent. So in section 5.1, you learned what congruent triangles are. All the sides and all the angles are congruent. They're identical twins. We're going to look at some congruence postulates that say, hey, if I have this information, I can prove that the two triangles are congruent. I don't have to show you every time that all the angles and all the sides are congruent. I just have to show you that these three pieces of information are congruent, and then we can conclude that the triangles are congruent. So it's kind of like using a shortcut. So the first congruency postulate out of 4 is the side, side, side congruency postulate that says if 3 sides of one triangle are congruent to the 3 sides of another triangle, then we can say that the two triangles are congruent. So for example, if side AB is congruent to side QP and side BC is congruent to side QR and side AC is congruent to side PR, I know by 3 sides of one triangle being congruent to 3 sides of a second triangle that by the side, side, side congruence postulate, these two triangles are congruent. So does the diagram give enough information to show that the triangles are congruent? Well, right now we have two sides of one triangle congruent to two sides of another triangle. Do you know that this third side in the left triangle is congruent to this third side in the right triangle? And you actually do. So JK is congruent to JK by the reflexive property because it's the same side. So we can say that JK is congruent to JK by the reflexive property. So now we do actually have 3 sides of one triangle congruent to 3 sides of the second triangle. So yes, we do have enough information to show that the two triangles are congruent. And SSS is my explanation. So here we're going to do 5 proofs today, 3 for side, 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 and 2 for SAS. So I already copied down the givens. Okay, you always want to write down your givens first. So they gave me these 2 pieces of information. So my reason is that they were given. And then they actually already have them marked in the picture as well. So those are 2 sides of one triangle congruent to 2 sides of a second triangle. So we're only missing one piece. Just like the last example, this is the third side in both triangles. GE is the third side in the top triangle and the bottom triangle. And of course it's congruent to itself, right? It's the same side. So of course it's the same length. So we know that GE is congruent to GE by the reflexive property. And now we have 3 sides of one triangle congruent to 3 sides of the second triangle. So by side, side, side congruency postulate, we can prove that triangle EFG is congruent to triangle GHE. And I just copied this down because that's exactly what we were trying to prove. Oh, we should have 3 tick marks here because they already used 1 and 2 tick marks. So this could be a different length than all of those other sides. Again, you first want to copy down your givens. So they gave us 2 pieces of information. You always want to go mark it in your picture. They only marked JL congruent to MK. So let's mark JK congruent to ML as well. JK congruent to ML, and I'm going to use 2 tick marks because they already used 1. And then just like the previous examples, the third side is shared, right? Side LK here is in the top triangle and the bottom triangle. So I'm going to use 3 tick marks, and we know that LK in the top triangle is congruent to LK in the bottom triangle because it's the same side, right? So we know that it's congruent to itself because it's the same. So that's the reflexive property. And now we have 3 sides of one triangle, 1, 2, 3, that are congruent to 3 sides of another triangle, 1, 2, 3. So by the SSS congruency postulate, we can prove that triangle JKL is congruent to triangle MLK. And I just copied down that right there because that is what we were trying to prove. This one has one additional step. So first, copy down your givens. So we have this given, which is already marked in our picture. AC is congruent to CB. And then our second given is that M is the midpoint of segment AB. So I'm going to highlight segment AB. Segment AB, and we know M is the midpoint, which means middle. Midpoint means middle. So it means it cuts segment AB in half. So we know that this half of segment AB is congruent to this half of segment AB. So we can say that segment AM is congruent to segment MB. And the reason we knew that was because of the midpoint. So our reason is definition of midpoint. This is called the proofs guide. First step, you're always going to write down your givens. Second step, these two steps can be interchangeable. So we actually just did the third step, and we found, since we were given midpoint in our givens, we had the midpoint. So we figured out what we knew because of the keyword. And then step number 2, let's look back at step number 2. Do we have reflexive property or vertical angles? We didn't have this in our first two examples because they were basic proofs, but you'll almost always have reflexive property or vertical angles in your proofs. So in this example, we have the reflexive property, right? CM is congruent to CM because it's the same side, right? So CM in the left triangle is congruent to CM in the right triangle by the reflexive property. So now we have 3 sides of one triangle, 1, 2, 3, congruent to 3 sides of second triangle, 1, 2, 3. So by the side congruence postulate, we can prove that triangle ACM is congruent to triangle BCM. And now we're going to look at the side angle side postulate, which says if 2 sides and the included angle, and this part is really important, of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. So what do I mean by included angle? So you guys see how it says SAS. A is between these 2 sides, so it's included. So between side AB and side CB is angle B. So you can see that this segment and this segment share B because they meet at B, which means that B is the included angle. It's the angle that's between these 2 sides. So that's really important when you use the SAS congruence postulate. It has to be the angle that's between those 2 sides. So here's an example. Side AB is congruent to side PQ, and side BC is congruent to side QR, and angle B is congruent to angle Q, and you can see that when I trace these 2 lines, B is the angle between those 2 lines. So that angle B and angle Q are the included angles. So we can say that these 2 triangles are congruent by the SAS congruence postulate. So let me just give you a non-example. If I give you 2 triangles that look like this, then those triangles are not congruent because that is not the included angle. Rather, this would be the included angle between those 2 sides. So copy down your givens. For time's sake, I already have them written down. So those are givens. Let's make sure they're marked in our picture. They won't usually be marked. Yes, they did mark JL congruent to LN. and they did not mark anything with the next one. So that's where step number 3 of this proof guide comes in. They gave us a midpoint. So again, we're going to know something by definition of midpoint. So L is the midpoint of segment KM. So let me highlight segment KM. And they told me that L is the midpoint, so L is the middle, which means that this half is congruent to this half. So we know that segment KL is congruent to segment LM. And we knew that because of the definition of midpoint. So at this point, we have two sides of one triangle congruent to two sides of another triangle. So let's go back to step number 2 on our proof guide. Do we have reflexive property or do we have vertical angles? We have, in this example, we have vertical angles. So let's look. We don't have any overlapping sides, but here are my two vertical angles, right? When you can draw the X, that's when you can recognize vertical angles. Do not call that angle L because there are 4 angles at angle L, right? There's 1, 2, 3, 4. So don't call that angle L. We need to use 3 letters to name those 2 angles. So this angle is angle JLK. And then I always use my congruence statement just to make sure I get the next one right. So JLK corresponds and is congruent to angle NLM. And how did we know that? Because those are vertical angles. And if you look, JLK is congruent to angle NLM. So you can see that they correspond. And now we have two sides of one triangle congruent to two sides. So these two sides of this triangle are congruent to these two sides of this triangle. And we have the included angle. So side, angle, side. Side, angle, side. So by the side, angle, side congruency postulate, we can conclude that triangle JKL is congruent to triangle NML. We have one more, I think. Yep. So copy down your givens. That's always the first step. And then make sure your givens are marked in the picture. In this lesson, they were. Most times they won't be. So they already marked SP as congruent to TP. And they actually have the next, they have the next one marked, but we're still going to have to write it in our proof. So PQ bisects angle SPT. So PQ is doing the bisecting, and it bisects angle SPT. So angle SPT is the thing that's getting bisected. So we're going to know something by the definition of angle bisector. Okay. Well, if the angle is what's getting bisected, so angle SPT is what's getting bisected, then we know that this half is congruent to this half, which they already marked for us. So we just have to write that. We know that angle SPQ, and we have to use 3 letters to name it. So angle SPQ is congruent. Now again, if you use your congruency statement, it just makes it easier. So SPQ is congruent to angle TPQ. And you can see that in your picture, TPQ. So yep, that is the angle we were talking about. And that's by definition of angle bisector. And then again, if you have angle written here, you better have 2 angles here, or else that does not make sense. So now we have a side and an angle. So we want to check, do we have reflexive property or vertical angles that are congruent? In this example, we have reflexive property. So PQ in the left triangle is congruent to PQ in the right triangle because it's the same side. So PQ is congruent to PQ by the reflexive property. And now we have enough information. We can say that, oops. We can say that triangle SPQ is congruent to triangle TPQ by the side angle side congruency postulate. Side angle side. So notice that this angle is the included angle. There you go. So side angle side, if I were to trace these two sides, they meet an angle, this angle right here. So this is the included angle between these two sides. So by the side angle side congruency postulate, we can say that triangle SPQ is congruent to triangle TPQ.